Have you ever wondered how you actually build an expert? I mean, you don't just throw a bunch of facts at someone and hope for the best. No, it's more like constructing something, piece by piece, right from the ground up. Today, we're going to look at the architect's plan for building a chemist.
So, yeah, how do you actually do it? How do you take someone from just, looking at the world around them, to truly understanding what it's all made of? It's not magic, believe me. It's a really carefully designed process, like an intellectual construction project.
And that whole process starts with the blueprint. Our source material for this is a first-term chemistry syllabus. Now, I know it might just look like a list of topics, but it's actually a step-by-step guide for building a scientific mind. So let's unroll this blueprint and get started with Section 1, laying the foundation.
Okay, so every great structure, every single one, needs a solid foundation. You just can't build a skyscraper on sand, right? Well, in chemistry, that means starting with the absolute non-negotiable core concepts that everything else, and I mean everything, is going to be built on top of. This first month is all about getting that groundwork right, and you can really see the logic here. We start broad in week 1, just a general intro. Then, boom, week 2 zooms right into the microscopic, this kind of radical idea that matter isn't just one continuous thing. Week 3 gives that idea a name and a set of rules with atomic theory. And by week 4, we're actually learning the tools to count and measure these tiny, invisible particles. You see? Each week is like pouring a new layer of concrete for that foundation.
Now, the blueprint really singles out Dalton's atomic theory. And for good reason. It's the bedrock. This is the big one. It's the moment the abstract idea of stuff becomes a concrete reality. The moment you realize that everything, the air you're breathing, the screen you're looking at, you, is made of distinct, countable little bits called atoms. Without this one powerful idea, nothing else we're about to build would have anything to stand on. It's that important.
All right, so the foundation is poured, it's set, and now it's time to start putting up the frame of the structure. This is where we learn to actually speak the language of chemistry, moving from just identifying basic materials to describing some really complex interactions. So before you can build anything, you've got to organize your materials, right? You sort them into 3 distinct piles. Think of elements as your pure, raw stuff, like individual bricks of iron or copper. Then you have compounds. That's what you get when you chemically cement those bricks together to make something totally new, like H2O, water. And mixtures? Well, that's just a pile of different bricks and maybe some sand, all just sitting next to each other, not actually combined.
So once you can sort your matter, you need to learn the language to talk about it. It's a lot like learning to read and write, actually. You start with the alphabet. These are the symbols for each element. Then you learn to form words, or in this case, formula, to represent compounds like water. And finally, you start writing full sentences, which are the chemical equations that describe entire events, these things we call reactions.
And this language, it isn't just for show. It's a super practical, problem-solving tool. Once you understand the words and the letters, you can do some amazing things, like figure out the exact mass of a molecule or calculate the precise percentage of an element inside a compound. This is where the abstract theory becomes a real hands-on analytical tool.
You know, any good builder will tell you, you have to check your work as you go. In school, we call these tests, but if we're looking at our blueprint, it's way better to think of them as quality inspections. They're designed to make sure the structure we're building is strong, stable, and, well, up to code.
And the blueprint schedules these inspections at really key moments. See, at week 5, the midterm is there specifically to stress test that foundation we just laid. Then week 10 isn't really an inspection. It's more like a reinforcement phase, a chance to go back, tighten all the bolts, make sure all the connections are solid. And the final exam, that's the certificate of occupancy. That's what certifies that the entire structure is sound and it's ready to be used.
So, we've walked through the blueprint, we've laid the foundation, we've framed the structure, we've even run our quality inspections. But what's the point of all this? Why does this particular plan matter so much? Well, the answer isn't just about chemistry. It's about the skills you build along the way.
This right here is the ultimate goal of the blueprint. You don't just finish the course knowing what Dalton's theory is. You end up mastering these core principles so you can actually apply them to solve new, real-world problems. And maybe more importantly, you develop the critical thinking skills to start asking completely new questions. You haven't just learned some chemistry, you've actually started to think like a scientist. And really, that brings us to the final question. This whole thing was a blueprint for building a chemist, sure, but the method, the foundational skills you pick up, that can be a blueprint for so much more. So the real question isn't just about what's in this syllabus,
It's, once you have a blueprint for knowledge, what will you choose to build?